All right, guys, let's go ahead and go through and work through some of these problems. Again, you should feel fairly confident with this already. This shouldn't be anything that's groundbreaking or crazy new to you. But let's just go through and make sure we can calculate these and feel halfway comfortable with them. Okay, so the first one, of course, is molarity. This is our go-to and the one that we should feel the most comfortable with. And if you cannot calculate molarity, that is something we definitely need to discuss. Okay, especially at this point in time, considering we've been doing it for a good bit here. So remember, molarity is moles over liters. So the first thing we want to do is convert to moles. Sorry, forgive Riley in the background. She is napping and making all sorts of noise. We need to convert our grams of our solute, sodium chloride, into moles. So again, we should be able to do this in our sleep by just setting up our train tracks. Okay, sodium chloride has a molar mass of 58.44 per 1 mole. Okay, and we do that math of 156.5 divided by 58.44 with 4 proper sig figs because of our 156.5. We get 2.678 moles of NaCl. Okay, from there, over liters, what we're given in milliliters. So we convert that into liters, and we end up with 2.678 moles divided by 0.876 liters. And we get a number of, hold on, there we go, of 3 sig figs because of our 0.876 of 3.06 molar, and that is a capital M. So pretty easy, no big deal. Okay, the next one's a percent by mass, okay, which again is going to be the mass of the solute over the total mass. Okay, and technically times 100 too because it is a percentage. So mass of the solute we already have is 156.5 grams. Now we need to figure out the mass of the total. So the big thing here is you need to understand that water has a density of 1.00 grams per milliliter. Okay, or at least that's our typical density that we work with. Okay, well, if we have 876 milliliters and there's 1 gram for every milliliter, we know there's 876 grams of H2O. Okay, so how do we get the total mass? We add those together. So 876 plus the 156.5. Okay, and that gives us a total mass of 1,032. I'm writing 33, sorry about that. 32.5 grams, and technically with sig fig's sake we should actually have 1,033 because when you're adding it's the least definitive, which would be our ones place because this guy doesn't have one after the decimal, but we'll go ahead and leave it. Okay, times 100, so 156.5 divided by 1,032.5 times 100, we'll call it 4 sig figs because that's what they probably should be, is 15.16%. Okay, so not too bad. Mole fraction of salt, we already have our moles, but mole fraction is just basically our part out of our whole. So what we need now is to get our moles of water. Again, pretty straightforward. So 876 grams of H2O, which we just calculated, divided by a molar mass of 18.02 grams per 1 mole. So 876 divided by 18.02 gives us moles of 48.6 moles of water. Okay, so from there, okay, we take our moles of sodium chloride, and I know this is a little bit messy, I apologize, I'm just going to come over here and do that, is 2.678 divided by our total moles, which is going to be the 48.6 plus the 2.678, and that's going to give us our mole fraction, which you can either leave as a fraction, just meaning those numbers the way they sit, or you can solve it out as a decimal. Typically I will solve it as a decimal, but it can be done either way that you want to do it. It doesn't technically matter in the grand scheme of things. Okay, and that gives us a mole fraction of 0.05, we'll say 223 for 4 sig figs. Okay, Okay, and last but not least is molality. Now, in reality, molality and molarity are different, but the numbers can be the same depending on the circumstance. So when I take the sodium chloride and dissolve it in water, what's going to happen is it's going to actually fill in the spaces between the waters, which means volume of water does not change. So molality is the moles of the solute over the kilograms of the solvent. Well, the kilograms of the solvent and the volume of the solvent, because it's a 1-to-1 ratio, 1 gram per milliliter, ends up basically being the same number. Okay, or in essence, with conversions and all that stuff. The thing where it starts becoming different in terms of molarity versus molality is when you start dealing with a solute that changes the volume, or with a liquid solvent or solute that will change the volume, which we'll look at one of those in just a minute. But in this case, they're going to end up being essentially the same number. So our moles of our solute is 2.678 moles of NaCl. We then need to get our kilograms of our solvent, which we know we have 876 grams, which means 0.876 kilograms. And again, the reason that's the case is because that is our solvent. Water is our solvent. So when we dissolve the 156 grams of sodium chloride into the 876 milliliters of water, the volume of water is going to basically remain as 876. So the volume of the total solution for molarity is 876 milliliters, or 0.876 liters. Okay, so that is why these two numbers end up being the same thing. But let's look at a circumstance where they're not the same number. Okay, so an aqueous solution is prepared by diluting 3.30 milliliters of acetone with water to a final volume of 75 milliliters. The density of the final solution is 0.993 grams per milliliter. This is where we start getting the difference between molarity and molality, because the total volume that we're going to use for molarity is not the volume of water that was actually used. So our volume of solvent and our volume of solution are going to differ in this case, therefore giving us different molarities. But let's go ahead and start with molarity. That's the easy one. Okay, the thing we need here is the moles of the acetone. We're given density and we're given volume. So the first thing we have to do is calculate our grams of acetone and then get that into molarity of acetone, or moles of acetone. So 3.30 milliliters. I'm going to use train tracks just to kind of solve this all out at once. Okay, and you can technically stop here, get your grams, and then plug that into another train track. I'm just going to go ahead and take it all the way through. Okay, and this is of our acetone, which is our C3H6O. Okay, and for every 1 mole of our C3H6O, we have a molar mass of 12.01 times 3 plus 1.01 times 6 plus 16. We have a molar mass of 58.09 grams. Okay, so when we go through and do this math, 3.30 times 0.786 divided by 58.09. And I'm getting a mole value of 0.0447 looking at sig figs, 3 sig figs of our acetone. Okay, from there we want to take that and put it in molarity. So molarity is moles over liters. And again, this is liters of the solution, which we're told our milliliters is 0.75. So molarity is going to be 0.0447 moles divided by 0.075 liters, converting our milliliters into liters. Okay, proper sig figs looks like 3 again, because you do have 3 here. I just didn't convert it all the way down here. So that's going to be 0.595 molar. Okay, so that's our molarity. Not too bad. Okay, percent by mass. Again, pretty straightforward here, but we need to get our masses. So we do actually have to come back up here and get our mass. So that might be a reason to break it down a little bit and do it in multiple steps instead of doing it in one solid step like I did here. Again, either way. So the first thing we want to do is get our grams of our acetone. Okay, which is the 3.30 times our 0.786. So we have 2.59 grams of the acetone. We're going to do the same thing with the water. Okay, and this is going to be a little bit more challenging. And in reality, it's not going to be too bad. And the reason it's not going to be too bad is because we're actually, for percent by mass, we're looking for the total mass of the solution anyways, and we're given the total volume of the total solution, so we can actually work it out the same way we just did, using the density of the solution instead, so the 0.993 grams per milliliter. Okay, so 75 times 0.993, and that's going to give us 74, oops, sorry, I'm writing 75. 74.3 sig figs, we'll say 5 grams. Okay, so if we want to find our percent by mass, we take our 2.59 and divide it by our 74.5, and we either can, nope, sorry, I'm thinking mole fraction. We find that number, so 2.59 divided by 74.5 times 100, and that's going to give us a percent by weight of 3.48%. Okay, mole fraction kind of works out throughout the same way. Only difference is here is we actually need to find the mass of the water. Okay, and we can do that by recognizing that this is the mass of the total solution and this is the mass of the acetone in there. So 74.5 minus 2.59. Okay, and that's going to give us 71.91 grams of H2O. Okay, can convert that to moles pretty straightforward. Okay, using our train tracks. Okay, and that's going to give us a mole value of 3.99. We'll just go ahead and call it 4 sig figs. Actually, I guess it should only be the 3 because that should only be 3 because of the 1 after the decimal there to do the subtraction. But that's okay. So we'll just say 3.99 moles H2O. Okay, from there we do our mole fraction, which takes the moles of the acetone, so 0.0447 moles of the acetone, over the total moles, which is 3.99 plus 0.0447. Okay, and again, we can either leave it like that or we can solve it out. So let's go ahead and solve it out. So we have 0.0447 divided by 0.0447 plus 3.99. Okay, and that gives us a mole fraction of 0.011, we'll say 1, okay, with 3 sig figs. All right, so that takes care of our mole fraction. Now, let's do our molality. Molality, again, is going to be different here because of what the equation is for molality. So let's just scroll down just a little bit, if it will let me. I apologize, Smartboard is being ridiculous. All right, so molality is going to be moles of the solute, which we already have. That is our 0.0447 over the kilograms of the solvent. Well, we already know the grams of the solvent, which is the water, so now we convert that into kilograms, so 0.07191 kilograms. So notice this is a different number on the bottom than what we had in molarity because it is a different species. Instead of looking at the full solution, we're just looking at the solvent. So 0.0447 divided by 0.07191, and that's going to give us a molality of 0.622. Molal, not molar. So again, notice a little bit difference there, and that's because of the fact that we're looking at solvent for molality versus solution for molarity. Okay, so hopefully this helps with your calculations. And if you have questions, just let Mr. Christie or me know. Thanks.